In this video, we will see code implementation. So now let's do the code implementation of unique paths. So I use this unique paths as a function. Unique paths function equals to function name with m comma n. Okay. Now what I will do, I will simply say create a DP. So I will simply create a DP of 2D array. So new array of size m, and I will fill it with mapping the elements. What I'm mapping again a new array of size n, and that I will fill with. Okay, this is my DP. Now I will create one function. Now you have here the function is unique path, so I can take given any function name. Let's call it as dfs I comma j. Will dfs of I comma j will be if suppose my I is getting less than 0 or j is getting less than 0, what I will do, I will return 0 directly. I is equals to 0 and not or and not this end, I guess this end. J is equals to 0, I will say yes, I have reached there, so I will return 1. That is one possible path. Now if dp has a solution, so dp of I comma j it's not equals to -1, that means I will say no need to do function call, simply return dp of I comma j. If it is not defined, so you need to do dp of I comma j equals to dfs, same function called dfs with I minus 1 comma j plus dfs of I with j minus 1, right? So I can do it separately. I can take upward and leftward, and then I can say upward and leftward plus, but I am doing in a single line. Then turn with dp of I comma. Okay, and my answer basically in the last will be, I can directly return the function call return dfs with passing m minus 1, the last point. Okay, m minus 1 and n minus 1. So I'm putting return, that means that comes under the function, this function. So I will put inside this function, and this was also one function. So yes, I am calling it here and I'm returning. So that is one of the approach that we checked. Okay, approach 1. Okay, now what will be the approach 2? Approach 2 where we are applying tabulation technique. So what we will do in this technique, again the same. I will use the exact same code and I will replace with the tabulation method. Let's see how. So I will copy this one here in approach 2. I need to create a DP, that is for sure. So no need to change here anything. Okay. Now what will be the things here? Instead of a function call, what I will do, I need to put this base case. I is less than 0 and j is less than 0. I need to put this case. So what I will do, I will simply start a for loop that will go when I equals to 0 to I less than I m I plus plus. What I will do, I will say dp of I comma 0 equals to 1. Okay, same case will go with the for the row, right? So basically I will start from 0, it will go till n I plus plus, and I will fill the 0th row, right? So this is for 0th column, this is for 0th row. 2 for loops done. Now what I will do, I will create one for loop that will start from 1 now. For let I equals to 1, I go till m I plus plus, and for let j equals to 1, j less than m n and j plus plus. Now again the same condition. Where was this? Yes, this one. I will put this condition instead of dp and dfs, it will be dp. So dp of I j, it will be dp, and I will use this bracket instead of this. Okay, and same with this one, so I will simply copy this one. Okay, I minus 1. Okay, I will say now I and j minus 1. Okay, so dp of ij will be dp of I minus 1 and j, right? And we have already filled this base case, right, of my tabulation technique. Now once this is done, what I need to do, I just need to return the last point, that is dp of m comma n, but instead of m, it will be m minus 1 and m minus 1. Okay, so yes, we have done with this one. I will simply remove. Yes, this is, we are not in function, so you can create a function, but this will be your approach 2. Now coming back to approach 3, then there, that means doing the space optimization. Okay, so if I copy the same, now I don't need to create a 2D array. Okay, I can create a single array. So no need to create a 2D array. I can create a single array of n columns and I am filling with 1. Okay, so when I filled with 1 my array, I don't need to require any space here, any base case, because I have already filled. Now this loop will be only the loop that will start from 1 to m, j to n, and I will fill dp of j. Okay, will be dp of j plus dp of j minus 1. Okay, only this thing, dp of j will be dp of j minus 1. It will go till n, and it is basically, this is running for m rows, but see, my row is continuously changing, right? I'm using the same row. Okay, and in the last, what I will do, I will return dp of what, dp of n minus 1, because it will go till the size is n. The last element will be dp of n minus 1. That will be my approach 3. Okay, so I have completed all the 3 approaches. Okay, you can directly go ahead, try these approaches, and you are good to go for this dp solutions. Okay, so that's all for this video. See you on the next problem.